So yeah, evening everyone. Thanks for dropping by. And big thanks to Lukas MM0OKO, who has joined us this evening to give us a talk on battery building. Something that I'm just been blissfully ignorant to and always wanted to do more research in. So very grateful for you taking the time. Without further ado, I'll pass over to you, Lukas.
Okay, thank you very much. And basically a small background about batteries. I started interesting in batteries a couple years ago. Basically, the big plan was to build a battery for e-bike. The e-bike is still in pieces somewhere in cupboard. Some cells are finished in radios, some cells finish in other projects, and some information just appear in between, what basically means it start working somehow. Okay, the screen it's here. Huge presentation, that will be a big word. Okay, start with a cut. How to make it bigger?
Yeah, that works.
That works. Now it should be. Oh.
Okay. The typical thing where it puts it on the other screen.
And basically, the cut works as a sum of chargers. The most annoying chargers that start lighting only when it thinks it's charged, fully charged. Well, basically, you don't know if it's charging or not charging, or dead or not dead, because manual says it start putting lights on when it's charged. But yeah, at the most annoying Chinese chargers. Then basically, what's a battery is? But basically a juice for radio, portable power source, more or less, depend what size, capacity, or if you would like to carry it or use it from a car. And basically source of fun, basically anyway, it can power your radio. It can make some sparks if you need it. If somebody are out of matches and smoking, you can do easy trick with some wire and use it as a lighter. Not recommended with lithium ions or any lithium cells, because they don't really like to be shorted, but it's working. Why to build your own? Mostly because it can be fun. You can customize it. When you build it, you can customize it. It don't have to be a square box that basically doesn't fit anywhere. You can build a battery designed to your radio to keep it the same shape or in the same rack. Pretty handy thing. I will show later. I'm basically right now.
Have you got dual screen by any chance? Because we can see the PowerPoint thing rather than slides.
I have no idea how to split it. If you tell me, then yeah.
Yeah, have you got on one of your screens, have you got like the side deck and on the other screen, the actual slides?
I think new share, pausing, security, stop video. Have no, more. What should I click to split the screen?
Apparently on the menu, you can click slideshow and then click swap screen.
Menu.
Oh, hang on. No, I know what you've done. Stop sharing.
Okay, stop sharing.
Yeah. Then go into share again. And there should be an option for desktop one.
Yeah, desktop one.
Yeah, pick that instead.
And that's right now.
Why to build your own? Because we can. Yes, spot on.
Okay, then it wasn't visible.
It was focusing on the application rather than the window.
Okay.
So
Okay, then basically.
Sorry about that.
No problem at all. That's up here experience with video calls. Exhibit number 1, pretty big and chunky one. But if you match it with exhibit B, it basically sits pretty nicely. If we add some racks or mountings, it can be one nice packet. And basically that can be built for any shape, any radio. If you like donuts, it can be in a donut shape. Only your imagination will keep you from taking basically shapes. Elements of the battery, cells, basically the main source of power, battery management system, or basically battery security or safety boards, what's more often can be bought from China for a normal money. Wires, casings, optional things like sensors, displays, communication modules. If somebody would like to get a communication module with Bluetooth, the BMS can be controlled via Bluetooth from the phone with a whole range of options like minimum voltage cathode, maximum voltage cathode. Quite a lot of fun. The issue is it's not always working as Chinese manufacturers are recommending, advertising. What else? Different cells type. Big one, prismatic cells. Square hard cases, very easy to stack, very easy to connect with bus bars, almost always using terminals with screws, female or male screws, threads, basically aluminum or copper bars. Very easy, very good to do. Can be built for solar storage, for example, or if you need a big battery bank, most likely used in cars or e-bikes possibly too, but that will be big and heavy. Small cylindrical cells, that will be the most interesting for us. Whole variety of size, capacities, types connectors, the same slightly bigger ones with screw connectors, pre-soldered tabs, button heads, what basically looks exactly like AA batteries, and most popular flat ends that need spot welder. Can be soldered, but it's very not recommended as those cells are pretty easy to overheat and then they're losing quite a lot of capacity. And pouch cells, easy to push everywhere. The issue is they are soft and they are expanding when you charging batteries. Then it cannot be packed very tightly, what some Apples and Samsung phones demonstrated in the past. The same pouch cells are pretty easy to connect because they have a nice big tabs or ready pre-soldered wires. Something telling me that will be pretty quick presentation. BMSs, chip protection boards, the easiest way to get from everywhere. Basically, you can get a BMS for, you choose BMS for the power you need and the voltage you need in a S format. One S, 2S, 3S. It's a serial connected batteries, but it is it's tiny one for 3S. In theory, should be enough, good enough for 10 amp power of deliver. Slightly more advanced with proper balancing circuits, good for batteries. Slightly more difficult to find one, the one that's really working and not so cheap. Other differences in BMSs that can be a common charge and discharge interface, most likely in lithium iron phosphide batteries, or separate interfaces for charging and discharging that more common for lithium-ion cells. SX, basically that's for configuration, how many cells we have in a series, and that will be for us from lithium-ion cells, most likely 3 or 4 in series. For iron phosphide, 4 cells is a bang on, because basically that gives us a car voltage batteries, and even car battery charger can be used to charging everything. Some cells are designed with or built basically with BMSs fitted straight into cells, like for example one of come on, I can't see what I show. Something like this. It's just tiny board stick to the cell itself. Sometimes it's this flat one on the side, sometimes it's a round one on the top. That's a pretty nice thing if somebody using this tiny nano or pico radio transmitters, because basically it needs one cell to operate, and it have a security circuit built in. The cells can have some issue if somebody would like to use normal rack casings or spring-loaded casings for cells, because they are usually slightly bigger than cells without built-in BMSs.
Quick question, if I can, on
Yeah.
that last cell you held up. So is that just a single cell and the BMS is there to protect it?
Yes, exactly.
Basically.
It just basically provide a low and high cathode. It prevent under and over voltage on the when discharging and charging. It's basically cathode power at 3. Oh, now I forgot the voltages.
So if you had like 5, if you needed, I don't know, 4 of them in series or parallel, would you be able to get one BMS to manage all of them, or would you have to have one to protect each cell? I assume you'd be able to get one to manage all of them.
Basically, if you have more cells, better use one BMS that will incorporate all cells at once, because at this moment one circuit knows what's happening in whole battery, and these tiny things are really don't care what's happening in other cells, and it can cut out 1 or 2 cells from whole battery, and then the rest of battery is just still working. What can be not very good, because they starting to be overloaded.
All right. So yeah. So you really just want one brain behind it all.
Yeah, that will work the best one.
Thank you.
And unless some devices are designed specifically with work with banks of independent cells and independent BMSs.
Okay, thanks.
Okay, what's more? Cables, connectors. Cables, that's a thing that's quite often underestimated. We like big, fat wires with a nice elastic silicone insulation. A lot of very thin strands inside of wire give us elasticity, and the cable will not break. And elastic silicone insulator, it's thermal resistant. What basically mean if we soldering cable, it will not shrink and do not expose any more conductor. What was pretty good for safety. And when the battery is under heavy load, the same the insulation will just do not start smoking. What's pretty important. The magic smoke, it's very difficult to catch and put it back, then better to avoid it. Connectors, basically completely freedom of choice, whatever you prefer. Just please do not twist and wrap on the battery terminals, because that always cause some sparkling and heating. That's pretty poor connection. RC plugs, The yellow ones, that's XC something. Usually there are 20, 30, 60, 90 amps, and plenty of power can be pushed through those tiny yellow plugs. Power poles, the same, up to 40 amps or 30 amps. I think up to 40 amps, these black and yellow, black and red ones. Spring-loaded connectors, easy to use, not the best one because they have pretty high resistance. And of course, crimps, the same, pretty nice, easy to use, just require a proper crimp tool. Work perfectly with batteries, especially if you have a bigger cells with threaded terminals. That make life so much easier just to fit it. Boxes, casing, packaging, again, whatever you can imagine. Pre-made boxes, 3D printed boxes, shrink wrap, everything. If it's thick enough to prevent damaging cells, it do not, and it do not, oh, sorry. And when it do not conduct electricity, it will work. For
How
us.
about waterproofing?
That depends when you will use batteries. Basically, we're trying to avoid rain because most of equipment is it's not waterproof. Then that's next exhibit. That's a pretty beautiful packaging with a freezer freezer bag and some paper tape. Good enough to keep it inside and rain outside. It will, of course, it's not submersible, but it's good enough for small rain just to chuck everything into bag and run away.
Fair enough. Yeah, the reason I ask is there's LoRa low-powered radio stuff. I'm keen to make a little pack that I can just. It's only like, I think it only runs on 5 volts, really low draw, and it'd be good to. I've got in my case, I've got an electric scooter, and one of the battery banks for one of the old ones that I used to have has died. So I'm curious if after watching this, I can repurpose it and have something that lasts for a long time.
Yes, no problem at all. You can use one, if it's 5 volt, you can easily get one cell or couple parallel cells from lithium ion and just connect them through a step-up converter, because the maximum voltage is 4.2, minimum volt is 3.6. Then you can step it up to 5 pretty easily, or just bolt 2 together, and then you will need a step-down converter. I think step-up is slightly better because you do not generate heat.
I'll definitely, when I've actually got into it and taken it apart and fully understood, I'll definitely shout if it's all right.
And about waterproofing, if I could remember, you have a 3D printer, then no problem at all. 2 pieces of plastic and O-ring around perimeter, and it's waterproof.
Fair enough. Vic says, what are the considerations with parallel and series connection of cells? I guess, I mean, I'm guessing he's assuming like mixing types or, yeah, well, his question just says, what are the considerations with parallel and series connection of cells?
Oh, that will be slightly further in this, because that's basically.
We'll stop interrupting them.
No, the problem with this material is that everything should be applied at the same time, and that will be even more confusing than my talking. Okay, basically tools, what we need: soldering iron and flux, spot welder. The one on the left one is a proper spot welder, bench spot welder from Sunco. It's work pretty well. I'm lucky enough that my colleague lent me one and forgot to ask me to get it back, probably because it's a pretty big box and it's handy for him when it's sitting in my place. The one on the right one is that something was pushed by Chinese very boundly right now. It's a battery-powered spot welder. Not very good because it's require itself a pretty powerful battery to work. And even if you can see on this small picture, the internals are not the best quality, and that's picture stolen from Chinese auction from eBay that's selling those things. And if you consider that that's pretty significant power as going through this machine, I don't want to use something with welding, with soldering wires that looks like this. Standard tools, spanners, screwdrivers, knives, heat guns, can be used hard dryer for heat shrink, even better because safer for cells, cream press, multimeters. Chargers can be pretty handy because we would like to keep all cells that we're connecting as close the same level as possible. Basically, if two cells are on different levels and we connect them parallel, they try to equalize itself in pretty rapid way, and that's pretty bad. One cell is almost shorted, other cell it's getting very huge charge very quickly, was overheating the charge. That cell basically can kill two cells at once. Balancing charger can be pretty handy later when we have a good battery and cheap BMS board. Every 10 or 5 full cycles, this will be pretty handy to connect the battery to proper balancing charger and make sure that our cells are leveled, because that increase capacity of our battery and increase lifespan of all cells. And of course, universal hot glue gun. You can basically do everything with this. And if something hits around, it's very good to hold them together. Like this small cells. Let's open this, because why not? Okay, that's come on. It looks like the fridge bag is pretty solid packaging for cells. Oh, that basically 2 parallel 3 in series with exactly this tiny BMS, and everything it's glued together with a heat gun, hot glue gun. Works pretty nice, and for now I didn't manage to discharge it with a TX 500 in last 5-6 hours of working. And then if something pulls so little power, even six small cells will be pretty significant for this. Difference between chemistry. Lithium iron phosphide. Both are good, they are just different. Lithium iron phosphide have a much more cycles if we consider full cycles, 100 to zeros. Lithium ions will start losing capacity from up to 80% with about 300 cycles. Lithium ion phosphides can get 2000 plus cycles. That depend from manufacturers. Lithium ion phosphides are slightly better for deep discharge. They are not so fragile, and they do not generate so much heat, and they have basically everything, everybody sitting in this. That's the positive. The next positive for iron phosphides is basically the voltage, nominal voltage. They are working pretty well with car chargers, what's pretty handy. What's worse, slightly lower energy density, what means bigger cells and more heavy. The curve of discharge is flatter. It's pretty difficult to check how much juice left in a battery unless we will get a proper BMS that can check it for us and tell us, because basically this battery, when it starts for 14.6, it's pretty quickly dropped to about 13-ish volt, and it stay almost all the time, and then just almost vertical drop to minimum 12.8, and the batteries, the BMS will cut out power. With lithium ions, basically higher discharge current. If we need more power and heat, 1 second. Stupid cat. Higher nominal voltage for cells, and that's depend from what we're using for. Because first we need special chargers for 3S or for 4S dedicated for the voltages, and the voltages minimum and maximum are sitting slightly different than design. The radios are designed, most radios are designed for more like car battery, 13.6, 13.8 voltage, and the cutout is about 11. Some radios can work lower, but 3S battery give us 10.8 up to 12.6. What basically mean if something is designed to start working from 11 volts or 11.5, we will losing half capacity of the bank. And the same with our 4S banks. Car charger, car battery designs radio are working on 13.8 volt. What probably will work without any issues up to 15 something. But again, almost 17 can be definitely too much for most of the equipment. The positive, it's much easier to check how much juice left in the lithium ions, because the discharge curve is much steeper, and precise voltmeter will tell us more or less what's happened. What's not so good in lithium ions, then can go bunk if they are overheated or damaged. Lithium ion phosphides are much safer. They do not tend to react so violently. Usually ion phosphides are just getting swollen and release some gas through safety valves. Lithium ions can make a cracking noise. I cannot find this information again, but I saw somewhere a comparison that lithium ion cells have a power density higher than a dynamite. Then it can be interesting if it go boom. Capacity and power. Basically, that's a calculation what power we need and how long we would like to operate equipment. What I'm usually doing is basically taking the maximum power that the equipment will draw. For example, radio. If radio is designed to maximum power of 20 amps, just for a safe measure, I like to add 25-30% and calculate whole battery for output of 30% higher. Again, the capacity depends if you would like to use battery for one event, short event, 1 day, a couple of hours. That can be nice, small battery, easy to carry. If you plan to using the battery for a couple of days, Basically, we have to double or triple capacity. Again, depend from the what use it's planned for batteries and what equipment will be powered, because power amplifiers, laptops, phones, all auxiliary equipment will take more power from the battery banks. I do believe this fat blue battery bank that I built will be enough for 2-3 days for powering the 50-watt radio plus laptop and something else. Designing the battery, and we're in the spot that you ask about connecting cells. Back to foundation, basically. License, if I could remember, that was something like this. Connecting cells, lithium ion phosphide in 4 pores, lithium ions in 3 or 4, and voltage regulator at the end. Parallel connection, again, depend from desired capacity, maximum output power, and charging speed. The more we have cells in parallel, usually the more power we can push into the batteries, what increase charging speed, and the same more power we can pull out from the battery if we need something with more to power something with more energy consumption. And that's some about weird shapes. That's basically photos from the bike batteries conversions. That's why small lithium ions are used for this. Battery, the power density, and basically the most universal shape. It can be shaped in any desired enclosure spots. If you have any box that basically fits radio, and you have some space around, it can be used to stick some cells and basically use it as a closed system with battery. The only thing we have to remember is only about cooling. Those batteries can be pretty hot. If you're charging or discharging them quick, then better using slightly smaller powers if the battery is sealed in some boxes. Connecting cells. Soldering, it is possible. Some people on YouTube, and quite a lot of people on YouTube, claiming that it's okay. They're using big fat soldering irons just to put a lot of heat in a fairly short time. I mean, 2, 3, 5 seconds. Cells are overheated, unfortunately, pretty badly. And what it's causing, basically, it's degrading lithium from the cells, and we're losing capacity. In the worst case scenario, that can be a chain reaction, and our battery start heating itself, and we don't want it. Spot welding, basically the best one. Very short time of heating, and there is no way to get bad connection. There is no connection, or there is a good connection with spot welding. Or try some spring-loaded contacts. They work. The battery will get bigger when we're using it. The connection usually is not very perfect, and we're losing at the resistance that will just hit itself instead of giving us all the power from inside. Why do not solder? That's the issue. I cannot embed the video. I just wasted enough time, and it doesn't look like OpenOffice don't like YouTube or don't like videos in general. If somebody is happy to watch this video, the guy is pretty good one. He's showing on the thermo camera what's happened with cells when they are soldered or spot welded. spot welded.
I'll be very cheesy. For those who are watching it afterwards, there'll be a link to that in the description below.
That's a hyperlink. Then probably if we drop somewhere the whole file, that can be easy to click.
Yeah, absolutely. No, it'll be because we're on YouTube. I can put like a little flashcard above us. That's where we stop the video. So yeah, I'll put it somewhere. It'll either be above us or it'll be in the link below.
Yeah, basically that's the video of the guy that I start thinking how to build a bike battery, and he published some pretty nice books, pretty short books basically, and easy to digest how to build the batteries. And I start my building experience basically from this guy's books and videos. Installing BMS, basically when all cells are connected as we want in groups and banks, basically most BMSs require that we have to connect control cable first. What basically means there is usually a number of cells cables on the control loom +1. The +1 cable goes to minus terminal of the battery, and then each next positive cable went to next positive terminal of each cell. When all of these cables are soldered, basically we can connect managing loom to the BMS, and after this we can connect main connectors, main fat cables to charge and discharge our batteries. And again, that's BMS with a common port. You can basically use the same one plug for charging and discharging both functions with the same battery. And the second type require second connector with a separate charging and discharging port. Usually charging port is much smaller because it doesn't require so much power. But that again depends from what we're expecting from battery. I do believe with a radio equipment, we do not draw so much power that we require. Very chunky connectors. 40 amps should be fair enough for everything. At least if we consider portable use. Casings, again, whole imagination, heat shrink sleeves. Blue one. Exactly, I do believe that's BMS from the same company that I steal those pictures. Custom project boxes, it can be used normal sealed electrical boxes. They are pretty nice because they are ready with a seal. Basically, we need to put a 1 grommet that will hold wires, seal it with silicone or something, put 2 screws, and the box is sealed. Custom designed, 3D printed, in of the layers of stretch film, Ziploc bags. Yeah, was pretty well. Whatever can be used basically to secure the cells inside. Do's and don'ts. Basically, very, very basic stuff. Most of things is common sense. If it's possible, use new cells and use the same model of cell. That's a pretty important, especially if you're using cheap BMSs, because those Chinese boards usually provide balancing only during charging process, what means if we charge with a normal power, I think even 1-2 amps will be pretty quick. Those batteries, those cells will be not able to balance itself. And then if you want to reuse cells, it's good to using balancing charger, proper RC balance charger. The battery with a safety board can be equipped parallel with balancing leads, charging balancing leads, and basically we'll have dangling one extra plug for a balancing charger. Very easy just to add mod, very easy to add mod to battery. Of course, we need then separate charger, and that's slightly more expensive. I think those chargers start from about 50 quids from slightly better ones. When building battery, make sure the levels are close as possible. The 500 volts, it's okay, and it should be provided by any cheap lithium-ion charger. The closer cells are, the better for cells, and less special effects. When we're connecting cells with a bigger difference, we quite often have some sparks, what can be pretty scary first time. Yep, I almost dropped my battery when I start shooting with mean sparks. Read BMS manual twice. That's too, because BMSs in general have the same manual, but not always. Sometimes they require other order of wire connections, and if we burn BMS because we just connect wires in wrong order, of course warranty will not apply. Cover all terminals that you're not working with something. Paper tape is usually good enough because it's easy to remove, it's cheap, and doesn't conduct electricity. Again, strip insulation only from working place. Don't strip wires on both sides of cable, because you're working at one end and the other end can wander on the other side of battery. Bad thing. Make sure you have enough time to finish project, or you can close it in the safe place. When the battery is built and it's not, or half built, the cells are connected, there is quite, basically it's a ticking bomb. Stupid ginger cat wandering can make a lot of mess. And what's happened? That was only 4 cells, and that's still vanadium. Oh, can you see? There is a nice spot. Vanadium still hardened spanner. I did not manage to bend it on anything, but one small short and it have a burned hole. And because that was lithium ion phosphide, nothing happened to cells. But if that will be a big battery and it will be shorted without fuse or BMS board, it can finish in interesting way. Fuse the battery. Yeah, that's a very good idea. And of course, no one of my batteries have a fuse. That's a very bad idea. And that's just everything once again. Do not short, do not cut, do not overheat cells, do not keep metal things close to terminals or metal tools. Do not leave project unsecured. And most important, do not keep simulator bottles of water and isopropyl close to each other. Isopropyl have a really awful taste. I can guarantee this. I just checked it. Really bad. And basically, that will be everything. And I do believe that's the best slide. Maybe this one, maybe this one and the first one.
The cats were good. There was a request early on to see the cat again. Don't let ginger cats lick the battery. Yeah, good idea. That was Dan. Yeah, Vic's question was about was about batteries, not cells. Some batteries shouldn't be connected in parallel, etc. I think I know what he's going on. I think there was something I remember a while ago about, like, if the batteries have got different chemical types, should you avoid mixing them together?
Definitely, because with a different chemical types, you have different voltages.
And different, I guess what
Yeah,
you're saying. Sorry, go on, Vic.
My question was because I was looking at batteries a lot on different internet places, and some of them had specifically explicitly said that they can be connected in parallel, or what I'm trying to say, come on, help me, in series. Yeah. So I'm wondering why they specifically explicitly said that they can be connected in parallel or series. Is there something that certain types cannot be? I don't know. Maybe they have maybe their BMSs don't work together, or I don't know. Just guessing.
If you're talking about whole batteries, then I do believe there is BMSs, the electronic don't like each other. There are some types of ready-made batteries that have an additional linking wire for connecting BMSs together, and basically the whole bank of batteries start working like one huge one.
Yeah, I think that's what it is. I was just a bit surprised that there is the auction specifically said it's allowed to connect them in any configuration. I was wondering, whether there's any situations, maybe there are certain types that cannot be connected, that way.
Yeah, I think that it's down to BMS, what's used in the battery. Basically, if BMSs do not talk to each other, it basically can finish one battery in a bank, can shut down. And if you have a couple of batteries in a series, just everything go down. That's no issue at all. But if you have batteries in parallel and ones go down, the remaining batteries will get whole load at once.
Yeah. Okay. Yeah. Sure. Okay.
Okay, just before I press stop recording so people can kind of talk more openly. Thank you very much. It's kind of been the perfect length of a talk because I'm armed enough now to feel like I can go away and do some stuff. It kind of feels like the barrier to entry is probably needing access to a spot welder.
It's not bad idea to get one, and it's not very expensive. You can get a Sunco for 100 something quid, I do believe. What's not so bad if you
yeah, I was going to say
how much money basically we pumping into other equipment, and one spot welder will set you for all batteries that you need.
There's of course an option to make a spot welder out of the microwave transformer, right? But
yes, but
no.
you have no any control on this one. You need at least a basic control over time and power, because again, it's very easy to boil those cells.
Yeah, sure.
I guess it's one of those where it pays for itself pretty quickly. Is it much? Do you feel like you save money making your own?
Basically, if we consider, I think yes, because to get the battery in a shape or size that I want, it can be bought, but then the price is jumping. If we get a battery that's closed in a standard battery boxes like those from Amazon, they are cheap, but they are not very handy. That basically looks like normal lead acid batteries, because that's the same box. It's only lighter. And yeah, if you try to get battery this size, basically I can go only for 3 of those for this tiny radio. I don't know if you can get in RC shops, but the RC batteries are pretty expensive.
Yeah, the RC stuff's over-spec'd for what we need as well. I used to build RC drones, and you get stuff that'll do 50C discharge, which you just don't need. But they make very small packs. But they're all custom made the way you described, right? So there's little cottage industry in RC of people making those packs.
Yeah, you have cells with a huge discharge power. but instead of huge discharge power for us, better will be a much bigger capacity.
Okay, I'll hit stop recording. We always have to say, please like and subscribe. We don't really. I have to say that on principle.
And comment.
And comment. Yeah, leave a comment. Don't really. Right, let me hit stop.